Answer this. If I shrunk down the universe and the Earth is now the size of a tiny grain of sand, how large, in comparison, would the observable universe be? The size of an orange? How about a watermelon? Maybe even a basketball? Well, actually, it'd be bigger than the sun. And not just by a little bit, by more than 30 times the size it is now. That's hard to get your head around, but if you come with me, I've shrunk everything down just like this so that we can finally get some perspective on how big the universe really is. At some 8,000 miles in diameter, Earth, to us, is huge. So huge that in a standard commercial airliner, it'd take around 45 hours to travel around its circumference. But in the grand scheme of things, Earth is a teensy-tiny speck of dust in relation to many of the other objects in our solar system. Take Jupiter, for example. It's the largest planet in our solar system, a gas giant 11 times the diameter of Earth, making it 88,000 miles wide. Of course, nothing beats our host star, the Sun, at 865,000 miles in diameter. At this size, it could fit some 1.3 million Earths inside it. Now, these are all large numbers, and it's extremely hard to get a sense of perspective. So, to fully understand the scale of the universe, let's scale down and use something we all know, like food. So, take the smallest and closest planet to the Sun, Mercury, which at this scale would only be the size of a peppercorn. Earth and Venus, being very close in size, would comparatively be about the size of a cherry tomato. Mars, on the other hand, would be a blueberry, Saturn is a large grapefruit, Uranus an apple, Neptune a lime, meaning Jupiter would be the size of a watermelon. But if Jupiter is a watermelon, what fruit or vegetable do you think the Sun would be? Maybe one of the largest fruits of all, the jackfruit? Or a pumpkin, perhaps? Maybe a marrow? A good guess, but I'm afraid you're wrong. Since the size of the Sun is 1,000 times the size of Jupiter, it'd be closer to the size of a large skyscraper. Imagine that, a small tomato on the pavement next to a skyscraper-sized vegetable. That's really how small the Earth is comparatively. And we haven't even ventured into outer space yet. Now, tomatoes and skyscraper-sized vegetables aside, Earth is an incredibly long distance away from the Sun. 93 million miles to be exact. If you and your friends took a road trip, it would take about 176 years to get there in a car going 60 miles per hour. And that's without P-brakes. This distance is also referred to as 1 astronomical unit, or 1 AU. This is a unit of length often used to compare the distances of other objects in space. Neptune, the furthest main planet from the Sun, is 2.4 billion miles away, equivalent to 30 AU. But it's not the furthest object inside our solar system. That title belongs to what astronomers think is a dwarf planet with an incredibly inventive name of, wait for it, Far, Far Out, or formally, Far, Far Out 2018 AG37. At 132 AU, Far, Far Out sits an astonishing 12 billion miles away from us and is believed to orbit the Sun once every 700 years-ish. So hang on, how big is our solar system really? There must be some sort of edge, right? Well, there is. The Oort cloud is a giant shell made of space debris, which astronomers estimate contains billions or even trillions of objects. It's considered to be a kind of gravitational boundary between our system and the next. Its inner edge is thought to be some 5,000 AU away, and its outer edge sits at an unreal 100,000 AU. That's right, we're talking over a light year away. That's the distance light travels in a given year, and 1 light year is approximately 5.88 trillion miles. It's kind of hard to imagine just how big all this is, so let's imagine we've got a cosmic shrink ray, and we've shrunk down the solar system from the Sun to Neptune. Our home system is now our home team, set on a 360-foot-long football field. The Sun, in this case, would be just 17 millimeters in diameter, the width of a dime, sitting on the goal line. Running further and further from the goal line, we'd reach a Neptune the size of a granulated sugar grain, 60 yards away on the opposite side's 40-yard line. So, we've nearly reached the end of the pitch. I wonder where far, far out would sit on the playing field. Well, this planetoid would be 2.5 pitches away. At 250 miles in diameter, far, far out would be as small as 2 strands of DNA, so invisible to the naked eye. And if the outer edge of the Oort cloud really is some 9 trillion miles from the Sun at its furthest point, then it would sit over 193,000 yards away, or 1,600 football pitches over. Let's say our solar system pitch is the MetLife Stadium in New Jersey. The outer edge of the Oort cloud would lie further than Philadelphia. Now, did you know that our solar system is just one of at least 4,000 systems in our galaxy, the Milky Way? Yeah, and we all thought we were so special. Well, how big would we be compared to the Milky Way? Let's scale down again and make our solar system, from the Sun to Neptune, the size of a US quarter. Imagine this tiny coin in the palm of your hand. Well, our Milky Way would roughly be the size of the entire United States. Yep, that, ladies and gentlemen, was just our solar system. I'm almost scared of how big this is going to get. If you find all this stargazing inspiring, you should bring the stars straight into your home. Our new poster will launch you straight into outer space, where you'll discover ginormous stars, deadly black holes, and faraway superclusters, up to the very edges of the universe itself. To get your hands on this cosmically cool poster, click the link in the description below or scan the QR code on the screen. Fill up your own space with this poster and be amazed at how big the universe really is. Now back to the video. As big as our Sun seems, it's just one of approximately 400 billion stars in our galaxy. They're some of the largest objects in the Milky Way, too, which are so big, they make our Sun look like a baby in a room full of NFL players. Well, very shiny NFL players, like Sirius A, also known as the Dog Star. Sirius is the brightest star in the night sky, twinkling at us from 50 trillion miles away. Now, our Sun has a radius of 432,300 miles and a diameter of 865,000 miles, or 1 solar radius and 1 solar diameter. Sirius has a solar radius of 1.7, equal to about 740,000 miles, with a diameter of roughly 1.47 million miles. This star is also around double the mass of the Sun, or 1 solar mass, at 4 octillion tons. That's a 4 with 27 zeros after it. Damn, who else is on the team? Well, Aldebaran is a red giant star, like our Sun, although it has a lower weight of 1.7 solar masses, so some 3.4 octillion tons. It's significantly bigger, at 45 times the size of our Sun, which is about 38 million miles in diameter. It's one of the easiest stars to find in the night sky, even though it's about 65 light years away, or 382 trillion miles. Betelgeuse is our next hit. Now, this star is over 700 million miles in diameter and is also 15 times more massive than the Sun, at 32 octillion tons, making it a supergiant. These are stars that are more than 8 to 12 times the weight of our Sun, and Betelgeuse is some 700 light-years away. Whoa. That's 4.1 quadrillion miles. But the largest confirmed star in the known universe just happens to be in our galaxy. This is UY Scuti, a star 1,700 times bigger than our Sun at 1.4 billion miles in diameter. In fact, you could fit 5 billion suns inside UY Scuti. To get our heads around just how huge that star is, let's imagine we replaced it with our Sun in the solar system. Well, its photosphere, that is the outer shell of the star, would extend beyond the orbit of Jupiter. Man, Earth's toast. Still hard to get your head around though, so let's use that shrink ray again. If we turned our Sun into a basketball, then UY Scuti would be over 1,000 feet wide, so about as wide as a large cruise ship is long. But it may not, in fact, be the biggest. If its size is ever fully confirmed, Stephenson 2-18 would put just about everything else in the universe to shame. With an estimated 1.8 billion mile diameter, it has 400 million miles on UY Scuti, which is 2,150 times that of the Sun. It would take 9 hours to travel around Stephenson at the speed of light. In comparison, it would only take 15 seconds to circle the Sun. It's so big, it could fit 10 billion of our suns inside it. So, how large is the Milky Way if it can contain all this stuff? Well, it's 100,000 light-years across. For some perspective, if the Sun were a ping-pong ball, the Milky Way would still be a mind-boggling 19 million miles wide. If you think our galaxy is big, oh boy, you are in for a surprise. We're zooming out now, further than man or machine has ever gone before. So far, in fact, that we can wave goodbye to our solar system. See, that's you, right there, that little dot in the spiraling Orion arm of the Milky Way galaxy. Actually, Earth is so small at this point, it doesn't even take up a pixel on the screen. But as big as it is, the Milky Way is not the only galaxy out there. In fact, both our galaxy and our closest neighbor, Andromeda, are the largest galaxies in what's called the local group. The local group is a collective of all the clouds, nebulae, and galaxies that span the diameter of nearly 10 million light-years. Andromeda is the biggest galaxy in the group, estimated to be double our size at 200,000 light-years wide, with 1 trillion stars within it. It's just 2.5 million light-years away from us, which sounds hella far, but on a dark, cloudless night, you can actually still see Andromeda from Earth. If Andromeda was kicking out more light, though, it would appear in the sky like this. Now, even though light moves at a rate of about 186,000 miles per second, the distance between us and Andromeda, some 14 quintillion miles, means it takes about 2.5 million years for it to reach us. So we're seeing it as it appeared 2.5 million years ago. How cool is that? Andromeda and the rest of our local group, in turn, are located inside the Virgo supercluster. This is a giant group of galaxies and at least 100 clusters, which are structures that contain hundreds of thousands of galaxies within each of them. This is the cosmic roof, which extends over all of our heads, stretching 110 million light-years in diameter, with a volume 100 billion times that of the Milky Way. Boy, do I feel like a speck of dust on a speck of dust on the back of a speck of dust right now. So within our supercluster is the biggest known galaxy in the universe, IC 1101. And it's an even bigger show-off. Not only does it have a diameter estimated between 403,000 and 550,000 light-years across, but it also boasts a star population that's about 12 billion years old. For comparison, our sun is only 4.6 billion years old. Plus, it hosts 400 times more stars than the Milky Way. And at its core lies one of the most massive black holes known to man. Black holes are objects in space that are so dense, being filled with condensed particles and cosmic matter, that not even light can escape their gravitational pull. They are extremely heavy, formed when stars collapse at the end of their life cycle. The closest black hole to Earth is 1,560 light-years away. Thankfully, this is far enough that our planet won't get sucked in. In fact, it would have to be closer than Neptune to make an impact. But if it ever got within a few thousand miles of Earth, the entire planet would be decimated and dragged into the black hole in a matter of minutes. What could be worse? Well, encountering a supermassive black hole. These occur when black holes merge together, becoming so dense they end up being more than 100,000 times the mass of the Sun. IC1101's black hole has a category of its own, however. It's approximately 40 billion solar masses in weight, and that's a lowball estimate. Some astrophysicists theorize it could be as big as 70 or even 100 billion solar masses. It's been dubbed an overmassive black hole, a term used for black holes that were born big. Yeah, they didn't need to grow or merge, they just came into existence like that. Thankfully, IC1101 is a billion light-years from Earth, so there's no immediate threat. While IC1101 contains a resident black hole within its galaxy, the largest singular black hole in the universe is the gigantic TON 618. Located 18.2 billion light-years away from us, at its top end, it's approximately 60 billion solar masses. In fact, these two black holes may be heavier than all of the stars in the Milky Way combined, which totals just 64 billion. And even scarier, black holes like TON are freakishly large, at some 240 billion miles wide. Once again, TON 618 is so impressive, it'd fall into its own ultramassive classification of black holes, which are more than 5 billion times the mass of the Sun. I need you all to know that I'm holding back on making a legendary Yo Mama joke right now. As we travel further and further into the deepest reaches of space, comprehending all these measurements and numbers visually is getting hard. So we're getting out the shrink ray again. Right, so if the Milky Way was about the size of a penny, Andromeda would be a safety pin 2 feet away. The Virgo cluster, lying at the very heart of the Virgo supercluster, would be a foot-long sandwich 50 feet away, and IC1101 would be nearly 833 feet away and the size of a USB drive. TON 618, however, would still be impressive. It'd be situated around 2.8 miles away, and even though it's just one object and not an entire galaxy, incredibly, it'd still be visible, about the size of a pinhead. That certainly makes the massive Virgo supercluster more manageable for me to imagine, but these superstructures just keep getting bigger. So, our Virgo supercluster is nestled inside yet another supercluster called Laniakea. See a pattern forming? We're part of just one branch of the Laniakea cluster, with 100,000 other galaxies stretching a total 520 million light-years. God, that's more than 3 sextillion miles. That's a 3 with 21 zeros after it. Its mass is 100,000 times the weight of the Milky Way, and it's so big that it's comprised of 4 subparts: Hydra Centaurus, Pavo Indus, Southern, and of course, the Virgo supercluster. Our closest neighbor is Hydra Centaurus, 127 million light-years away. The Hydra part of this cluster alone is about 10 million light-years long, 1,000 times more than our Milky Way. Could we be any smaller? Surprisingly, Laniakea is not actually dense enough to be bound by gravity itself. So, wait, what's holding us all together? Well, turns out it's actually anchored by an even larger coalition of clusters and galaxies, which is collectively called the Great Attractor. This is Laniakea's central gravitational point, which stretches across the Virgo and Hydra Centaurus superclusters for 300 million light-years. Without it, we'd probably be floating somewhere in space with no stars in sight. But here's a twist. The Milky Way is gradually being pulled towards this force. This fatal attraction is responsible for pulling our galaxy in its direction at about 134,000 miles per hour. Yep, we're hurtling through space at an incredible speed right now, and we don't even feel a thing. Want to know why? Well, if the Milky Way suddenly accelerated or decelerated its motion, we'd definitely feel it. But because our galaxy is constantly on the move, we don't feel any change in motion at all. Scientists discovered that we were racing through space thanks to microwave background radiation. This is the emission of energy and light coming from objects left over from the earliest days of the universe, which allowed them to identify that we're moving closer to this force. Fortunately, we'll never actually collide with it. Unfortunately, that's because dark energy, a theoretical force that acts in opposition to gravity, will rip the attractor and our supercluster apart before we get anywhere near it. Although, luckily, this isn't predicted to occur for another several billion years at least. But even Laniakea's demise is just a needle in a cosmic haystack. Now, if we look out even further, we're about to find an even bigger threat looming over our heads. The pattern continues the further out we go, as Laniakea is located inside yet another structure, the disturbingly large Pisces Cetus. It's a supercluster complex formed of 60 clusters in total, with a mass of 10 quintillion solar masses. Okay, that's... wait, I don't even know how to say this. 40 quadrodecillion tons? So 40 with 45 zeros after it. Pisces Cetus is a galaxy filament, which are the largest known structures in the universe. These filaments are composed of dense, thin strands of dark matter, which is hypothetical matter that doesn't emit light or energy, and galaxies, which can stretch over millions of light-years. As a complex of so many clusters, Pisces Cetus is estimated to stretch over 1 billion light-years. It's so vast, the Virgo supercluster only takes up 0.1% of its total mass. Whoa. But is it the biggest, you ask? Not even close. Another galaxy filament, the Hercules Corona Borealis Great Wall, is a lengthy title deserving of its 10 billion light-year length, making it the largest single entity in the known universe. It's located in the northern hemisphere, inside the Corona Borealis and Hercules constellations. But it covers an area much wider than that, from the Boötes region to as far as the Gemini constellation. In fact, 10.7% of the diameter of the observable universe is taken up by the Great Wall, and its various galaxy clusters span over 20 constellations and 125 degrees of the sky. It's so gigantic, it's previously cast doubts on the famous Big Bang Theory. That's the leading theory for how the universe began. The Big Bang posits that the universe started at a single incredibly dense hot point which exploded, creating the majority of the universe's matter, the resulting forces, and is the reason why the cosmos is constantly expanding outwards. So, following that theory, it takes light 10 billion years to reach us from the Great Wall, meaning it must have formed 3.8 billion years after the Big Bang, as the universe as we know it is estimated to be 13.8 billion years old. But astrophysicists claim this is too short a time frame for an object to have grown so exceedingly large. A structure as complex as the Great Wall wouldn't have been possible because it completely ignores the understood gravitational limits of the early universe. Scientists are still debating whether we've got the universe's age wrong, and if so, this threatens everything we know about the evolution of the universe. Maybe it's just an anomaly we don't yet have the answers for? Well, either way, I think we can agree that the Great Wall makes us all feel small. So we've discovered the biggest thing in space. What then is the furthest? This is a galaxy called HD 1, the most distant object in the universe, and one of the oldest. This galaxy is seen as it was about 324 million years after the Big Bang, meaning it could be home to some of the universe's very first stars in existence. Physically, HD 1 has moved further away since then, and lies an incredible 33 billion light-years away. That's 198 sextillion miles. Man, how far even is that? Well, if you were traveling there in a car speeding at a constant 60 miles per hour, it would only take you about 377 quadrillion years to reach it. Hey, who's got the snacks? And even more importantly, what's beyond that? Well, that's where the physical boundary of the observable universe currently lies. A little over 46 billion light-years away, in all directions, as a sphere with a diameter of 93 billion light-years. Within our known universe, there are several hundred billion galaxies, and more stars than all the sand on Earth, which is about 7.5 sextillion grains. Like our planet, many consider the universe to be a sphere, or completely flat. But for all we know, it could be shaped like a donut, and some studies suggest that this could actually be the case. Scientists measured temperature fluctuations in cosmic microwave background to reveal the geometry of space, with some results pointing to a universe that runs in parallel lines, expanding in every direction, therefore making it flat. Others found that the direction of these cosmic rays changed over time, which indicated a more curved, round universe. And this is because the rays possess electrical charge and behave the same way when traveling through the Earth and its magnetic field, which we know is a sphere. Sorry, not sorry, flat earthers. But some have suggested that the universe might be the best of both worlds. If you had a piece of paper and drew parallel lines on it, and then cut and taped it at the edges, it would become a cylinder. Then, if you curved the two ends of that cylinder together, you get a donut shape. The parallel lines still remain parallel, but the universe now has curves. And as a bonus, it looks delicious. Of course, when we talk about boundaries, we're only actually talking about how far we can physically see in the universe. So why can't we see the rest of it? Well, this is because light has not been able to reach Earth from farther away, as the time it would take for light to travel from such distant objects would be greater than what we understand to be the current age of the universe. As the cosmos grows older, more light will be able to reach Earth from beyond this horizon. But sadly, the light from many objects will never be able to reach us. As a result, we don't actually know very much about infinity and beyond. Scientists estimate that the observable universe is at least 250 times larger and at least 7 trillion light-years wider than the known universe. But for now, we'll stick with what we know. And try to shrink it down again. Alright, let's turn the Milky Way into a grain of sand, barely 1 millimeter. How big would the rest of the universe be in comparison then? Well, the Virgo supercluster would be the size of a guitar, and Laniakea would be about the size of a canoe. Pisces Cetus would be about the size of a small city bus, and the Great Wall, however, would be slightly taller than the Statue of Liberty, from ground level to torch. Last but not least is the observable universe. How big do you think that would be compared to all the other objects? Maybe the size of an Olympic swimming pool, or even a house. Wrong again. The diameter would be more than the height of the Burj Khalifa in Dubai, the tallest building in the world. Now we've journeyed to the ends of the universe. Can you believe how truly gigantic space is? Well, next time you look at the stars, I bet you won't think they're so small anymore. Ready to explore the universe in your space? Grab your poster today. Just click the link in the description or scan the QR code. Okay, honestly, I don't know whether this information about the universe has left me with a greater feeling of comfort or a case of existential dread. How small do you feel right now? Let me know down below, and thanks for watching.